Hello and welcome to this episode of T-Tech. First of all, welcome back. This is part 2 of 3 in our series to configure OpenBSD as a firewall. Now, in this part, we're actually on the OpenBSD machine, and we're going to configure all of those functions that we talked about in our introduction. So, a quick summary of what we're going to do. First, we're going to set up our LAN and WAN interfaces, okay? Then, we'll set up our PF rule set, which is going to tell OpenBSD how to filter our traffic, so that'll be the firewalling functions. Then we'll set up IP forwarding, so it knows how to route that traffic. So in our introduction, how we talked about that destination address lookup, that's what that will enable. And lastly, we'll set up DHCP, so we're able to give our LAN clients IP addresses dynamically. So let's get right into it. So the first thing we'll do after logging in is run ifconfig. Now this tells me all the interfaces that this system has in it. Okay. The ones we're interested in my case, are EM0 and EM1. Okay. Now EM0 is going to be our LAN interface, so we're going to put our respective addresses on there from the diagram. And EM1 is going to be our WAN interface, so our internet connection. So how we go about configuring these interfaces, in OpenBSD, any interface is configured in etc/hostname dot and then whatever the interface name that OpenBSD gave it is. So we're going to use vi as a text editor, and we're going to make a file in etc called hostname.em0. And again, this is our LAN interface. First thing we want to put is tell it what type of IP address we're putting in here. We're going to put an iNet or a NIT for an IPv4 address. That will be 192.168.1.1, and our net mask is going to be 255.255.255.0. Now that's can also be referred to as a CIDR. That's a CIDR/24 as well. Now, what that means though, the IPv4 addresses are represented by 32 binary bits, so ones and zeros. And what the netmask or CIDR notation tells us is how those 32 bits are divided into a network portion and a host portion. Now, the network portion is like a street, okay? And the host portion is like the houses that are living on that street or built on that street. So in this case, if you see 255s in this is called dotted decimal notation, that just means all those 8 bits are on. Because each octet here, each section between the period, is 8 bits or 1 octet. And 255 is when all of the bit values in the octet are ones. Okay? And our bit values from right to left, they double by powers of 2. So it's 1, 2, 4, 8, 16, 32, 64, and 128. It sounds boring when it's just said like that, but regardless, this means all of them are on because all those decimal numbers add up to 255. And that means the first, third, and second octets are all part of the network portion, so they have to be the same. And if they're the same, we're in our same network or broadcast domain. But as soon as any of them change that don't reflect this netmask or CIDR, that's when we have to send our packets to our default gateway, because they're not part of our network, see? So that's how that works, and I just wanted to explain this at a very basic level, so it makes a lot of sense. So to save that, because that's all we need for our LAN side, we're going to type Shift and hit the Z key twice. And that saves that file. Excuse me 1 second. Alright, now we'll set up our WAN. Again, it's in the same place, but instead of EM0, it's EM1, okay? Now, there's two ways to set this up. Now, if our internet service provider is giving us an IP address over DHCP, we just type DHCP. Simple as that. And it will automatically set that address up for us on boot. That's all we need for the other. Then we would just save. But in our diagram, we had a static address. So we're going to set that here. Same thing, actually. We're going to say init 192.168. Now 0.25 with a /24. Now, very important to drive the point home about the mask and CIDR. Same deal as before, but as you can see, the first 3 octets there have to be the same to be in the same network. First and second is the same as our LAN, but the third is different. So that means they're on a different street, essentially a different network. So that's what I'm talking about there, and that's how the router's figuring out what networks are what. But anyway, that is our WAN address, and we need to set that static gateway, okay, the default static route. We're going to use an exclamation point. This means OpenBSD runs this command when it boots up. So we're going to say route add default, and our gateway is 192.168.0.2. And again, you would put whatever your ISP gave you if you have a static address for your internet connection. Now Shift-ZZ to save that. And now what we'll do is set up the packet filter. First thing we'll do is back up the original file, so we're going to use CP for copy. In etc pfconf, we want to back that up to etc pfconf.back, okay? And we'll just remove the original and vi a new version we're going to make. So again, hit enter, and now we're in our file. The first thing we're going to put in the file is something called macros. Macros are a variable, and they hold information like an interface name, IP address, or port numbers. So we put that information with a friendly name, and we can use that in our rules. It makes managing this a lot easier. First thing I'm going to put is LAN equals, and then in quotes I'm going to put my LAN interface we just configured in our hostname file. So EM0, and now under that we're going to put WAN equals EM1, and again, same thing from the hostname files. So that configures that, and we refer to those in our rules, and you'll see that in just a second. So now we're going to set some runtime options. First thing we'll set is set skip on LO0. This is telling PF to ignore packets on the loopback interface. Okay, the loopback interface is primarily used for testing, but there's more advanced uses for it, like your router IDs when you do OSPF, the routing protocol. But we don't need to worry about that. The main thing is set skip tells PF to ignore packets and let them all pass on the loopback. Next, we're going to say set block-policy to drop. This tells PF what to do when it sees a block rule, okay, when a packet matches it. There's two things we can do. We can either drop the traffic on the floor, alright, and don't send a response at all, or there is return. Now there's the difference with return versus drop. Return, if a packet comes in that's destined to a port that doesn't have anything listening on it, okay, or we're blocking it in other words, the return will send a packet back to the sender, okay? And if it's TCP, it would be a reset acknowledgement, or if it's UDP, it would just be ICMP port unreachable message. But there is a response that's sent back when it's set to return. This response can be used by tools like Nmap to discern if a port is open or not. So that can be a security risk because the attacker has information about it. Okay, but drop just does as it says. It doesn't let anything go back to the sender. So there's less information and less chance of them getting information about our system. So under this though, we're going to start writing our filter rules. Now, PF processes packets from top to bottom, with the last rule that matches the packet being the last action that is going to get taken on that packet, okay? There's actions of pass and block, and there's a little bit of sub-actions on the packets as well in the rules, but regardless, there's going to be a pass or block rule that matches at the end. So this also means, though, you have to make sure you position the rules in the rule set with thought given to the order. So the first thing I'm going to put in the rule set is block, drop, all. This is going to block all of our traffic by default. This does not matter where it's coming from, going to, what protocol it is, what port, interface, anything. It's just going to be dropped completely. If we don't add anything else, that last match rule logic will just hit this block drop all rule, and nothing is going to happen. All of our traffic's going to be dropped. But this is a great way to start because it's an implicit deny. Everything's being dropped, unless we add exceptions, which is what we're doing now. We're going to say pass in on, and now we're going to utilize our macro by saying $ and then our macro name up above, so LAN in our case. From is our source. We're going to set this to LAN : network. So this is saying any packets coming in on our LAN interface that are coming from our LAN network. So 2 is our destination, any destination, and now we're going to say keep state. Now, the pass is the action. In is the direction. If it's coming into the interface, it's coming into the firewall. If it's going out, it's being routed out that interface. And on, of course, is specifying the interface. From is the source of this traffic. Now, in our case, by saying $LAN, it means EM0 goes in place of LAN, alright, of that macro. And the : network is going to be replaced by whatever network we have assigned to EM0 in our case when we load our rule set. It makes maintaining this a lot easier. And the 2, of course, is the destination, and any means any other destination. The keep state is a crucial concept in PF. The state table in PF holds information about existing connections, so any connection is going through the firewall. Now, any packets that match this rule, so essentially any packets coming in on our LAN from our LAN network, are going to create state. That state is going to be things like the source IP address, the destination IP address, the source and destination port numbers, and the protocol. Alright, so the 5 criteria for keeping state. There's other things as well, but those are the main criteria for it. Now, under this, we're going to say pass out on our WAN from our LAN : network, just like before, to any destination. But now we're going to do this, the network address translation we talked about. We're going to change the source of our LAN network to be our one public address. So to do this, we're going to say NAT -2, and then in parentheses, we're going to say $WAN, and then keep state. Okay, the NAT2 specifies we want to change the source of the packet. So the main action is pass, but we're doing like sub-actions on the packet where we want to change the source in this case. The WAN is our EM1 interface, and that's the source we want to change it to, the IP address that's assigned to the WAN interface. The parentheses help us if we do that, the DHCP, we get our address dynamically from our ISP. That will automatically change it, and it will be able to keep routing packets. with the correct address. If we don't have the parentheses, we'd have to reload our address, and new connections would not work. Now lastly, we need to let the firewall itself talk so we can do pings and updates and things. So we're going to say pass out on our WAN from our WAN :network to any destination, and we're going to keep state. So that's our 4 rules for our basic firewall. This is going to allow LAN traffic to come in, destined to anything in any port and protocol and all of that. And it's going to route it out to our internet over our internet connection, while changing the source address to the one public IP on our WAN interface. It's also allowing the firewall itself to talk to the internet. Alright? Now the one thing it is not allowing, and you may have already noticed this, there's no pass-in rule on our WAN interface. What that means is, the only traffic that's going to be able to come back into our LAN is packets that are part of a connection that's already in our state table. So the only thing that can make state is if our LAN comes in to our LAN side and gets routed out and the source is changed, or if the firewall itself talks out on its behalf. All right, we've sent traffic out. All right. Everything else from the internet though will be denied. Everything else is going to hit the last match rule of block drop all, if it isn't in the state table or it doesn't match those 3 rules. So that is our pf.conf file and how we're going to set it up. So Shift-ZZ to save it, and we're going to verify this with pfctl-nf in etc pfconf. Now the no IP address found errors will go away once we restart and OpenBSD assigns those IP addresses. Now, the next step is for us to set up the IP routing. To set this up, we need to change a kernel tunable, which tells OpenBSD if it should route packets or not. So we're going to say vi/etc sysctl.conf, and we're going to type net.init.ip.forwarding equals 1, and that enables IP forwarding on boot. So again, we'll save the file in the same way, and that sets that up for us. Now, last thing we have to do is configure DHCP, or Dynamic Host Configuration Protocol. We've got to configure the server. Now that is in etc dhcpd.conf. The first thing we want to put in our file is option domain-name, and then in quotes we'll just specify whatever domain name we wish. Again, this is for the local resolution of the subnet, so we don't have to worry about it as long as it's valid. Now in this, with a semicolon, alright, and under that we're going to put option domain name servers. And these will be the DNS servers we give our clients that will allow them to resolve domain names into IP addresses. So we're going to choose 4.2.2.1. You have to put a comma, space, 4.2.2.2, and then end the line with the semicolon again. Now, we have to tell the DHCP server what subnet it should lease from. Okay? To do this, we'll do subnet space 192.168.1.0, or LAN subnet, and we'll say netmask 255.255.255.0. Now we want to open this block with a curly brace here, and enter down a couple times, and tab in. And here is where we're going to tell it what addresses in the subnet it can lease. Now, if we take the network ID there, the 192.168.1.0, and the netmask of /24, that tells us that our usable range of addresses is 1 through 254. And out of all of those addresses, we can tell the DHCP server what ones we want to lease to our clients. We're going to say range space 192.168.1.100 space 192.168.1.200, and that with a semicolon. And this is the range of addresses that we're able to give our clients. Enter down and tab in, and now we want to specify option routers space 192.168.1.1, and that with a semicolon. This is our default gateway that we're giving our clients. It's important that it has to be the LAN IP address, okay, of EM0 in our case. But make sure it's the LAN IP address. Now we'll enter down and wrap all this in one last curly brace, and that is how we configure our DHCP server. We're going to save this, and just like we did with pf.conf, let's verify this with a dhcpd-n, and there's no output, so there is no errors, and the file is ready to go. The most common errors I've made is mistyping an IP address or missing a semicolon. So, if you did make an error, it will tell you when you go and fix it. But, that's me. It is ready to go. So we'll go ahead and summarize what we've configured. We've configured our LAN and WAN interfaces, our DHCP server, our pfconf, and our IP routing. Now there's a few more housekeeping things we do have to do here. We're going to use rcctl to enable the DHCP server on boot. Alright, and we're going to also disable a few services. We're going to disable SMTPD because we don't need to relay email, and we're also going to disable SNDIOD. Alright, we don't need sound output. So, those are the last few housekeeping things we have to do. So, at this point, we'll quick reboot and do some quick verification, and I'll see you in a second. Alright, welcome back. We're booted back up. So, the first thing I want to verify is if my interfaces got the correct IP addresses. So we'll say if config for that. And I want to look at EM0 for our LAN interface, and you want to look at the init line for the IPv4 address. And it got 192.168.1.1 and its correct net mask. Now again, remember it got that because of the hostname.em0 file. Same thing for the EM1. That's why it got those configurations. So EM1 again has the correct init line of 192.168.0.25 and the correct net mask. So our LAN and WAN interface configuration is set. We're going to verify our PF rules with pfctl-sr to show the rules. All of our 4 rules are loaded, and all of our macros are resolved, and our :network syntax resolved into those networks. So we're all good there. What I would do at this point as well, we'll verify connectivity real quick. So ping to google.com. And we actually need to specify some DNS servers because we use static. So we want to go to etc resolve conf. And we'll put in some name servers real quick. We'll just put in one for testing. But if you have DHCP, you will get the name servers automatically. So we'll ping, and there we go. And if we do netstat rn-f for IPv4, we see our default gateways put in because of our !route command. Let's verify our IP routing with sysctl tac a, and then we'll pipe that input into the output into the input grep and look for forward. That is set to 1, again because of our etc sysctl.conf. And lastly, we'll verify our DHCPD. So we'll do a top command real quick, and DHCPD is process number 52307. So DHCPD is running, our PF rules are loaded, our LAN and WAN interfaces are configured, and our IP routing is configured. So with all of that, that is part 2 of 3. And in this part, we configured OpenBSD's functions in our network, our routing, our firewalling, and our DHCP server. So, I will see you in part 3, and I'd like to thank you for viewing, and have a nice day.